We got one message, record updated. Right, guys? Right, guys? So now, see here. So now, check this output. So right now here, I'm giving right now 60. I'm giving right now 60. Is it 60 is available? No. Okay. 50. Is 50 is available? Yes, exactly 50. Here we got a message. One row updated, guys. Means record updated. The record is not available. No record. The record is available. Record. After that, this is yes, 68 minutes Secunderabad. Yes, exactly. So this is example, guys. So this is example, guys. So by using percentile row count to percentile, okay, percentile type of percentile row type. Right, guys. This is. So these are some basic examples of our PLS scale. DDL means how to use that DML commands inside this PLS scale block. Okay. Right. So now we are discussing right now control structures. Control structures. What are the control structures? Control structures. Control structures. Control structures are used to control flow of the program. Flow of the programs. May see an example, above example, guys. Suppose here this is a control structure, if condition. Okay, if you're not given this if condition, what happens? The program is executed sequence of order, right or wrong? Line by line element is executed. Once you give the control structure, then if the condition is true, this block executed, the condition cross, another block is it means here you can control your execution of your program by using control structures to flow of the programs. There are PLS scale supports different types of control structures. PLS scale supports different types of control structures. That is. So one is conditional control structure. Second one is branching control structure. Iteration control structure. Unconditional control. These are the 4 types, guys. Conditional control structure, branching, iteration, unconditional. That is. Now, first one is conditional control structure. Okay. Conditional control structures. Conditional control structures. Condition control structures are classified. Condition control structures are used to control flow of the program. Sorry, control structures are classified into four types. One is simple if. Second one is if else. Third one is nested if. Fourth one is if else ladder. These are the simple if else, nested if, and else if ladder. That is case. The first one is simple if. Simple. It contains only true block. It contains only true block. It contains only true block. Right, guys? See one example. So here for this simply there is no false block. It is contains only true block only it contains. Then so now declare flag boolean equal to, we can input flag value. Flag value means that flag value true or false. We can declare flag boolean flag. Now begin. If flag equal to true, then dvms underscore output dot put underscore line. We are in true block. We are in true block. Completely fixed. After that, just we can display status messages. Put underscore line. End of the program. And slash. So suppose here my inputting flag value is true. Then your variable is true, sir. True equal to true now? Yes, exactly. Then we are in true block. And end of the program also displays. Okay. So Shaileja, this is called as to take the input. To take the input runtime. To take the input at runtime. That's why you're using ampersand symbol. This is input operator. While executing the program, the system is asking, flag value is asking, okay, C. Flag value is true, then we are in true block under the program. Suppose false. False to true now? No. End of the program only displays. Yeah, end of the program displays. This is right, guys. This is one example, guys. This is one example. Next, second one is if else. If else case. Yes, if else. Okay. Guys, tomorrow no session, guys. Tomorrow and day for tomorrow, no sessions. Okay. Means Wednesday, Thursday, December 6th to December 7th. Okay. Coming 2 days. Okay. No sessions. Next session on Friday, we have the session, guys. Friday, we have the session. Okay. Yes, Pushpesh, why are you giving end of means? This is syntax, guys. Here, before this example, we read the syntax first. Syntax. If condition, then executable statements. Else, sorry. Ending. This is simply for syntax. If the condition is true, block is executed, end if. End if means this end we can close here. This is an end if. In C language, we have open curly bracket, closing curly bracket is there, but here we write end if. Okay. Now, what about the if else now? It contains both true and false blocks. It contains both true and false blocks. That is. Right, guys. What is syntax? If condition, then executable statements. Else, executable statements. And if enough, guys. If the condition is true, this block is executed. The else means if the condition is false, this block. This is called as true block. This is a false. Enough, guys. This is a true block. This is a false block. So now, example. Write a PLSQL block. Write a place block to find biggest of two numbers. Write a PLSQL block to find the biggest of two numbers. So, declare A number of two equal to ampersand. B number of two equal to ampersand. Begin. If A greater than B, then BPMS output dot put underscore line. A is big. Else B is big. And if your program slash. This is enough, guys. If A greater than B, then A is big. Else B is big. Suppose my input value is 10. Here my input value is 20. 10 greater than 20, yeah? 10 greater than 20, yeah? False. A, B is big. Yes. Suppose here, if the A value is 20, B value is 10. 20 greater than 10? Yes. B, A is big. A is a big, no? 10, A is big. B is big. This is one example, guys. This is the if else. Right? Understand, guys? Simple program. Okay, to understand. Same like right now, I try to increment. Another example. PLS block for to find to increment. PLS block for to increment employee salary. So declare I declare V employee number EMP dot EMPNO percentage type is equal to ampersand employee. V underscore salary. Increment, na? Okay, increment not required. V underscore increment AMT. Number we declare. Begin and slash. Now update EMP set salary equal to salary plus V underscore increment underscore amount. Here also we try to input employee increment salary also increment underscore AMP. Employee increment. To whom to increment? Where employee number is equal to V underscore M. Here, at the time of executing our program, I am given right now 7902 is the employee number to increment 500 rupees. So 7902 employee salary is incremented to 500 rupees. After increment this, I want display status message. If SQL percentile row count is greater than 0, then dbms underscore output dot put underscore line increment successfully. Else record not found. Employee record not found. That is end. Completed, guys. This is the program. The employee record is available. Successfully, your record is updated and incremented successfully. Okay. That is. So 7902, 500 rupees. Sorry. Ampersand is missing. Okay. $7,902, 500 rupees. Updated. 9,000 employee record, 1,000 rupees increment. Employee record, no. Simple case. This is an example of if else. Okay. Next, third one is nested. Nested. If within the if is called as nested. If within the if. If within the if is called as nested. If followed by another if. If condition, then I check another condition again. Then execute the statements. Else, execute statements. Else, here, if the condition is true, this block is executed. The condition is false, this block is executed. Suppose the outer condition true, the outer condition is true, then check one more condition. If this condition is true, then some statements are executed. That is, this is the example. Yes. This is the example. Right. So this ND for this one, guys. This ND for this one. Total final ND for is outer block. Simple to understand, guys. How many ifs are open right now? 1, 2, 3. Here 1, 2, 3 and ifs. That is syntax. Here inner if close. Here inner if close. This ND for outer if. Okay, Pushpesh? Right. So we know a basic example for this nested if in our BTech or MCA standards. In the records, we place this program, a common program, guys. See, PLSQL block for to find the biggest of the numbers. Biggest of the numbers. To find the biggest of the numbers. That is. So, declare I take A number of 2 equal to ampersand. B number of 2 equal to ampersand. C number of 2 equal to ampersand. Okay? Then begin. If A greater than B, then means, guys, here A value 30. B value 20, C value 10. Okay. So first A with B I am comparing. So 30 greater than 20, A is greater than B, yes. That means A is big, na? So we can compare A with C also. So if A greater than C, again condition is true. A is big. That means 30 greater than 10. Yes, A is a big. Here, if A greater than B, again I check if A greater than C also. A greater than C also. If it is true, guys, then DBMS output dot put underscore line A is bigger. Yeah, no. Okay. A greater than B, 30 greater than 20. 30 greater than 20? Yes. But C value 40, suppose. Next, 30 greater than 40. 30 greater than 40. Is the condition is true? No. Condition is false means C is big. Because if A greater than C, condition is false, C is big. Right or wrong? So, else, what do I write down? C is big. C is big. You know? Ending. Completed. Okay. This block is for if A greater than B, suppose. Okay. Now I changed A value 20, B value 30. Now 30, 20 greater than 30, 20 greater than 30, false. Then control come to here. False means 20 greater than 30 means condition is false, na? Means B is big. A greater than B, condition is false means A is not a big, na? B is big. So then control come to here. Again we will compare B with C. Okay. If B greater than C, 30 greater than 10, yes, exactly. So B is big. Suppose here 30, here 40. Then 30 greater than 40, false. Then else block is big. And if your program slash. This is what to find the biggest of three numbers. Simple, guys. If A greater than B, A is compared with C also. If it is true, A is big. Else C is big. Completed. If A greater than B, condition is false. At the time B is big, na? Control come to here. Again B is compared with the C. The B greater than C, then B is big. Else C is big. Okay. Right. B is big. A is big. C is big. Right? So once the program is executed, you should be checked with different inputs. Understand, guys? Right, guys. Next one is, fourth one is nested if. If else ladder. Sorry, not if else, else if ladder. Else if ladder. By using this control structure, by using this control structure to check multiple conditions. Continuously. To check multiple conditions continuously to check. That is, guys. Okay. Guys, tomorrow no session, guys. Day after tomorrow also. Coming 2 days, no sessions, 6th and 7th. Okay. 8th is the session. Friday we have the session, guys. So by using this control structure to check multiple conditions continuously. See the syntax. If condition, then some executable statements. Else if, again condition. Then again I check one more condition. Else executable statements. And this is the example, guys. If the condition is true, this block is executed. If the condition is false, this condition is false. I can check another condition. If it is true, this one. If it is false, I can check another condition. Means if you want to check this multiple conditions continuously, then else if ladder is required. And also observe this, how many conditions you are opening here, only one and if is enough. Okay? But in every example, what happens? 1, 2, 3 ifs are opened. You should be right 3 and ifs. But here, only one and if is enough. It means some program logics are depends upon this type of syntax action. That's why we are using this. Else if ladder. Observe this ELS IF, guys. There is no E. Here there is no E. Only ELS IF. That is called else if. Else if. That is. Okay. Right. See one example. PLSQL block for to find PLSQL block for to display or to input student average marks and display grade. So declare v underscore avg. I declare as number of 5, 2. Okay, equal to ampersand average. Begin, guys. If v underscore average, if any student average is greater than or equal to 70, then dbms underscore output dot put underscore line distinction. Else if v underscore avg is greater than or equal to 60, then first class. If it is 50, second class. Or else pass, third class. Third class. Third class. End it. End your program slash. The student got greater than 70 average distinction. If it is greater than 60, first class. Greater than 50, second class. Yes, third class. So 90 average distinction, 56 average second class, 68 average, 47 average third class. This is nice. Okay. So this is an example of if you want to check these multiple conditions continuously to check, then simply we can use this else if ladder. Okay, guys. This is. Guys, the next session we'll discuss remaining control structures. We'll discuss one by one. The next control structure is branching control structure. Branching control structure. Okay, guys. Coming session we'll discuss. Okay. So tomorrow no session, guys. Tomorrow day after tomorrow no session. Okay. Right. Less than Pushpesh greater than equals to and less than equals to. Yes, we can use the Pushpesh. That ones we can use. But once you write that number of conditions one, then what happens now? Performance is decreased. Performance is decreased, guys. That is the problem. Okay. What you say that logic, that is also good. We can write, no issue. Greater than 70 and less than or equal to 100. Greater than 60, less than or equal to 70. Yes, you can write. Okay. Any doubts, guys? Right, guys. Okay. Thank you.